All right, sorry, the last one ran over just a little bit, so picking up where we left off. We have these formulas for how to factor, so now we can factor. Up top, okay, we have that difference of squares, x squared minus 9. Keep that 3 out front, is going to factor x plus 3, x minus 3. And the denominator, the difference of cubes, is going to factor x minus 3, x squared plus 3x plus 9. Okay, and what we see here is that both top and bottom have that x minus 3. So the whole x minus 3 can cancel. And on the bottom, all we're going to have is that trinomial, x squared plus 3x plus 9. Now up top, we have the x plus 3, but we also have that GCF of 3 that we took out right at the beginning. So what we're going to do to have this in its most simplified form is redistribute that 3 back through. So 3 times x gets us 3x, plus 3 times 3 gets us 9. And I know some of you guys are looking at it as saying, hey, the top has 3x plus 9, the bottom has 3x plus 9. We can cancel that whole thing. Not quite. Okay, that 3x plus 9 in the bottom is part of x squared plus 3x plus 9. That trinomial is locked together. So either you cancel the whole thing or you cancel nothing at all. So we're going to keep it exactly as is. Okay, and there we go. All right, let's take a look at number 4 here. Yes, sir. Mm-hmm. Say again. We distributed it back through. So 3 times x gave us 3x, and then 3 times 9 gave us that, excuse me, 3 times 3 gave us that 9. Yeah, when you go to your finished expression, you wouldn't typically leave it as those separate factors. You would multiply everything back through if there's whatever's left over. Good question. Okay, how about 4? Something should be almost panic inducing about number 4. X minus, yeah, that negative 2 exponent. Okay, not panic inducing, but it definitely reminds us of some stuff. What does a negative exponent mean? It's in the wrong place. So that x plus 3 is going to get moved up to the top. Okay, and don't write it just yet because I want to show you guys something. Okay, it goes up to the top, and it's not in the wrong place anymore, so it's got a positive exponent. Okay, but what does it mean to square something? Multiply by itself. So since we're looking at canceling some stuff, let's write it twice, just so that we can see if one of them cancels and the other one doesn't, or if they both cancel. Okay, now in the bottom, we still have the x squared minus 2x minus 15. Okay, this has already been moved up to the top. Okay, so we don't have to worry about it. We just want to factor the x squared minus 2x minus 15. Who thinks they can factor that one for us? X on both sides. One's plus, one's minus. 5 and 3 is going to work. Other way around. 5 gets the minus, 3 gets the plus. Remember, larger outer or inner gets the same sign as bx. Okay? All right, and what do we see here? A pair of x minus 5s cancel, and a pair of x plus 3s cancel. So all we're left with is that x plus 3 on top. Well, we can't just have nothing under it. If you got a fraction, you got to have something underneath there. 1. Okay? So we can have times 1 right there. So what we have is x plus 3 all over 1. But what happens when you divide by 1? It stays the same. So really, our answer is just x plus 3. And I don't know about you guys, but I would much rather work with x plus 3 than that very original expression that they have with all kinds of crazy business going on. Yeah.
So like, how do you get like the x minus 5 on the bottom?
Okay, so here's what we're doing. We're factoring every expression. So we had this x squared minus 2x minus 15. We rewrote it as x minus 5 times x plus 3. Okay, the same way up top when we were looking at the numbers. If I can scroll, I don't know if I can. The same way up top when we were looking at the numbers. Okay, we took 30 and rewrote it as 6 times 5. And we took 36 and rewrote it as 6 times 6. And the reason that we did that is so we could see both numerator and denominator have that 6 that can cancel. Okay, so the same thing goes on down here with those polynomials. We rewrite them in terms of their factors, and then those factors cancel. Okay?
So like, what's easier to 15 to get 5?
Okay.
5 and 3.
Yeah. Factors of 15. You got 15 and 1 and 5 and 3.
Oh, so it's just the guessing how you.
Right. It's the factoring thing we did from a while ago. Yeah.
All right.
Good?
Yep.
All right. Next up, number 5, last one. We got x squared plus 9 over x to the 4th minus 81 times x minus 3 to the negative 1. All right. So first up, x squared plus 9. What is that? It's not quite. It's the sum of squares, which doesn't factor. Okay. So that x squared plus 9 is just going to hang around. Okay. How about the x minus 3 to the negative 1? What's that negative exponent mean? It's in the wrong place. So we're going to take it and move it up top. And once we move it up top, it's not in the wrong place anymore. So its exponent is positive. Okay, and like we said, anything raised to the first power just stays the same. Right. So then we got x to the 4th minus 81. Okay. Hopefully we look at that and we say, hey, that's the difference of squares. Okay. What are we squaring to get each of those? Well, 81 is the easy one. 9. And good. X squared squared. So how does that factor then? Use that quadratic model. Plus 9 and minus 9. Great. Now hang on just a second here. This x squared minus 9. That's another difference of squares. What are we squaring to get x squared? And to get 9? Okay, so that means that this can factor even further. Okay, so up top we've got x squared plus 9 times x minus 3. And in the denominator, we've got x squared plus 9 times x plus 3, x minus 3. Good. Okay, now look at this big mess. And what do we see? X squared's plus 9 and the x minus 3's. Now I can't have a fraction with just the x plus 3 in the denominator, so what's on top? Good. So I've got 1 over x plus 3. And that's a whole lot cleaner than what we started with. Now, most of what we've got here, guys, is just plain old quadratics factoring with a little bit of sum of cube or difference of cubes mixed in. Okay, but all we're looking at each of these is factoring. Okay, factor as much as we can in the numerator and denominator, and then cancel whatever common factors we have for each. That's really all there is to it. Now pause for a minute though, take a look at all 5 of those. What questions do you have about any part of any of them? Yeah. Oh, just stretching. Okay.
How are we gonna know when we're gonna have to do what we did? Like some the difference of cubes.
Okay, so how do we know when it's going to be those special factorings? That's stuff you got to watch out for. Okay, remember we said we know how to factor a quadratic. We know how to recognize a quadratic. Ax squared plus bx plus c, done. Okay, but if you see variable with an exponent, so like x squared and a constant. Typically, if that's going to factor, it's got to be one of those special cases. And at that point, the only thing that you can really do is know those squares and cubes. Okay, if you know those squares and cubes, or at the very least, have your exponent chart at the ready. Okay, that'll help you recognize, okay, this is difference of squares, this is sum of cubes. That's how I'm going to factor this one. Okay, great questions. What else you got? All right, so one more time. Factor up top, factor down low. If there's a common factor in both of those, cancel it out and rewrite what's left. And that's all that we have to do here.